Hello. So we just finished learning about the electron configurations in the periodic table and some of those families of elements and their properties. And now we're going to be looking at the trends in the periodic table that occur naturally as the atomic number increases. So we know that the periodic law, we talked about this before, says that the properties of the elements are functions of their atomic number. Before we talk about those properties and those trends, we need to learn about a few keywords and terms here. First of all, there's the nuclear charge. So the nuclear charge is simply the number of protons in an atom. So for oxygen, for example, which you see on the screen here, oxygen has 8 protons, so therefore its nuclear charge is 8. We give nuclear charge the letter Z. The core electrons, which is represented here by the letter S, the core electrons are those electrons that are in the inner filled shells or energy levels. So here for oxygen, you can see that oxygen has 6 valence electrons. Those are the ones around the outside here. These are the valence electrons. And it has 2 core electrons because energy level number 1 has 2 electrons, and that's the full energy level. These are the valence on the second energy level for oxygen. Shielding an effective nuclear charge. So shielding, what this means is that the core electrons, they kind of protect those valence electrons from the positive charge of the nucleus. So they decrease its effect on the valence electrons. And remember, the valence electrons are the ones that are reacting. So those are the ones that we're very interested in. For each core electron, which has a negative charge, of course, it cancels out 1 positive charge from the nucleus. So the net effect is what's left over. And we call that the effective nuclear charge. Again, it has the letter Z for nuclear charge, but you can see here we have a subscript of EFF for effective. So the effective nuclear charge is equal to the nuclear charge minus the number of core electrons. Again, with our oxygen example, oxygen's effective nuclear charge is 8 minus 2 core electrons, and its effective nuclear charge is plus 6. So the effective nuclear charge is what's going to determine the trends in the periodic table. We cannot look at simply any one factor. You cannot look at just the radius of an atom or just the nuclear charge of an atom. You have to look at the effect of both of these things. So in the next several lessons, we'll be learning about the impact that the effective nuclear charge has on the trends observed in the periodic table. Let's first take a look at some of these questions. The nuclear charge is equal to the number of